Hello students. So today we'll be discussing a very interesting topic, which is how to find out the pressure force on various kinds of surfaces and various kind of walls which are exposed to fluid. So before we can start this discussion, the prerequisite concept that you should know is how to find out the pressure force on any vertical wall. So to find out the pressure force on a vertical wall, the concept that we should know is that the force is equal to the pressure at the center of mass of the wall multiplied by the area of the wall. Now, what is the pressure at the center of mass? If pressure here is P naught and the center of mass is at a depth HCUM, so pressure at the center of mass of the wall will be P naught plus rho G HCUM into area. If we expand this, we get this expression P naught A plus rho G H by 2 into A. Now, another way to write this is, this can be written as average pressure by into area also. So average pressure will be P naught, which is at top, plus pressure at bottom will be P naught plus rho GH. So if we take the arithmetic average of these two, this will be P naught plus rho GH by 2. That will be P naught plus rho GH by 2 into area, which is same as this. So to find out the pressure at the vertical wall, we need to find out the pressure at the center of mass or the average pressure and multiply it by the area of the wall. Now let us change this case. For example, take this case. So this case is a hypothetical fluid prism in fluid. So there is a container filled with a fluid, and in that we have taken a hypothetical shape of the fluid, which is in shape of a prism. And we try to find out what is the force on this slant surface. Now students, let the length of this part be L and this part be also L. Now if this angle is phi, what will be this angle? If this angle is phi, this length will be L sine phi. Now the students, what will be the area of this side? The area of this side will be, this length is L and this is L sine phi. The area will be L square sine phi. And what will be the area of this slant surface? The area of this slant surface will be simply L square. Now, because this particular prism of the fluid is in equilibrium, so the net horizontal force on this fluid prism should be 0. Now, what will be the force on this particular surface? Now, this is like a vertical wall again. So we can find out the force on this wall as, which is Fa. So we can write down Fa to be equal to P naught plus rho G L sine phi by 2. That is half of this length multiplied by area of this surface. Now, what is the area of this? It is L square sine phi. Now, this force will be equal to the horizontal component of the force applied on this slant surface. Now, on this slant surface, the force is represented by Fc and the horizontal component will be Fc sine phi. Now, this will be also equal to horizontal force on slant surface. Now, students, I advise you to note this expression down. Pause the video for a second, note this expression down as we move to the next slide. Now, there is another way through which we can show the same result. And now, what is this way? Let's assume that there is an aquarium. And one wall of the aquarium is slant. Now, let us try to find out the force on this slant wall. Now, the way to do it is, we take a distance y and a small strip dy along this slant surface. Let this length be L and this length is also L. Now, dear students, if the pressure at the surface is P naught, then the pressure at this strip will depend on the vertical depth, which is, if this distance is y, this is y sine phi. So the pressure here is P naught plus rho G y sine phi. If we multiply it by the area of this strip, which will be nothing but L into dy, we get the force. So this is the force. And by integrating it from 0 to L, that is along this length, we get the net force. Now on integrating, we get this result, which will be P naught plus rho g L by 2 into L square. And if you see correctly, what is P naught plus rho g L by 2? Sine phi. P naught plus rho g L by 2 sine phi is actually the pressure at the midpoint of this wall, because L by 2 sine phi is half of this height. This whole height is L sine phi, so half of this height is L by 2 sine phi. And the midpoint of this and the midpoint of this will coincide because of the geometry. So the pressure at the midpoint of this wall multiplied by the area again, but the direction will be in this direction. So this is the net pressure force. Now, dear students, if we try to find out the horizontal component of above force, it will be the pressure into area into sine phi by simple vector algebra. And if we substitute the value of P average into area, that is this value, we get this to be equal to P naught plus rho g L by 2 sine phi into L square sine phi. So as you can see, this expression, and as we move backward, then this expression, both of these expressions are same. Now, as we have got these expressions, we'll see the significance of this. Now, to understand this significance, we must know what is this L square sine phi. L square sine phi is actually the area of this face. And what is this pressure? Pressure is at the midpoint of this face. So pressure at the midpoint on this face multiplied by area of this face gives the horizontal component of force on this surface. Now, dear students, this gives us the concept of something known as the projected area. Now, if we want to find out just the horizontal force on surface, imagine a horizontal light ray on this land surface. Now, what kind of shadow will this horizontal light ray produce on a vertical wall? It will produce an area just like this. So this is called as the projected area of this particular slant surface. The area of this projected wall is L square sine phi. So this is known as the projected area. And what is the area of slant wall? It is simply L square. We can see that the projected area is area of slant wall multiplied by sine phi, kind of resolving the area itself. So a shortcut to find out the horizontal forces, we instead of dealing with this slant surface, we deal with the shadow of this surface if a horizontal light is falling on it. And we simply multiply the average pressure with the area of that wall. Now let us see how this can help us in solving very complicated questions. Now see this example. If we are asked to find out the pressure on this curved cylindrical surface, and let this be a wall of a fluid container which is filled up to its depth. Now, dear students, to find out the force, all we need to take is the projected area, and as we need to find out the horizontal force, the projected area will be this. The pressure at the center of mass of this projected area will be simply P naught plus rho g L by 2, as L is the total length, multiplied by the area of this projected area. Now this is length L multiplied by the breadth, which is 2r. So L into 2r. This will be simply the force. We don't need to go through the integration. A simple result will give us the force. Now let us take this example. If the container is such that the wall is a spherical wall, then the force on this will be simply the pressure at the center of mass of the projected area, which will be a circular base, which will be P naught plus rho gr multiplied by the projected area, which will be pi r square. Now again saving us from a very complex integration. Now let us take some more examples. Let this be one of the examples. I have also given this example in this sheet that I've shared with the batches. Now let us read the question, dear students. You can read the question, pause the video and try to solve this. The question says, in the figure shown, the heavy cylinder is resting on a smooth surface which separates two liquids of densities 2 rho and 3 rho. We have to find out this height. Now the students, here since this cylinder is in equilibrium, so net force on cylinder must be 0. So all we need to do is to find out the force due to this 3 rho liquid and due to this 2 rho liquid. Now to imagine this particular case, this is a cylinder which is extending backwards to a length L. So what will be the projected area? The projected area, dear students, will be somewhat like this, kind of a huge rectangle of depth R. The shadow of this on the vertical wall will be this only, like a rectangle of depth R. So the pressure force due to the 3 rho liquid can be simply written as 3 rho into G into R by 2. That is the pressure at the average point of the projected area, which will be this, multiplied by the area of this projected area, which will be simply R into L. That is R into the length L. Now similarly, this is F1. That is it due to the 3 rho liquid. We have to find out F2 due to the 2 rho liquid. That will be the density 2 rho. Now the students, here the rectangle will be formed of a height h. So this will be 2 rho into G into h by 2. That is the pressure at the center of mass of the height h multiplied by h into L. And if we equate F1 is equal to F2, we get our final answer, that is 3 rho G R by 2 RL is equal to 2 rho G H by 2 HL. We have to find out the value of the H. So we get the value of H to be equal to root 3 R by 2. Now let us try to solve another question. For example, this is a question. A thin walled hemispherical shell of mass m and radius r is pressed against a smooth vertical wall. Through a very small aperture, a water of density rho is filled in it completely. The minimum magnitude of force to be applied on the shell for the liquid to not escape from it. The weight of the hemispherical shell is mg and the total mass is given as this. We have to find out the net external force to keep this in place. Now students, you can again pause this video and try to solve this question. Let us see how we can solve this now. The students, the external force required to keep this particular hemispherical shell in place will be equal to the net force applied by this liquid on this hemispherical shell. So dear students, we can divide the force applied by the fluid on the hemispherical shell into two parts. That is the horizontal force and the vertical force. Now to find out the horizontal force, it is pretty easy because again, this is a curved surface and all we need to do is take out the projected area of it, and the projected area will be a circle of radius r. So the horizontal force Fx that we can write down will be rho g r, that is the pressure at the center of this projected area into pi r square. So this will be giving us the value of the x component of the force due to the projected area. Now, what will be the vertical force? The vertical force can be calculated as the vertical force on liquid in magnitude will be equal to vertical force on shell by liquid. So I can correct. In the above, it is on liquid by shell. Now, how much force will be applied on the liquid by the shell? That will be the weight of the liquid. By the way, the above expression is due to the third law of motion. Now, what is the weight of the liquid? That will be, as given in the question, equal to mg. It is also given that m is 2 by 3 pi cube rho, which is simply volume into density. So, this can be also changed as 3 by 2 pi multiplied by 2 by 3 pi r cube. Let me just rewrite it again. This can be written as 2 by 3 pi r cube rho into g into 3 by 2. So this will be giving us 3 by 2 mg. Now, to student, this doesn't complete our task. There will be another vertical force on this shell, and that will be the weight of the shell as well that we need to add in it. That will be small mg. So the resultant of this force and these two forces in the vertical direction will give us the net force, and that solves this question completely. Here is the summary of the result and the solution. You can go through it. Now, student, this is how we find out the force on various curves